The building is still half asleep, and the hallways feel padded, like they were designed to swallow footsteps. Overhead, the lights stay dim on purpose, and the air has that clean, dry scent of filtered patience. You might think a lab like this is all drama and hero moments, but it is mostly doors and badges and quiet habits that keep you steady. Tonight, you step into a night shift where safety is not exciting. It is repetitive, soothing in its own strange way. With the Sleepless Scientist murmuring in your ear, you will move through locked corridors, careful layers of gear, and the gentle science of not touching what should never touch you. Slowly, calmly, you will learn how boredom can be a kind of protection. Your first lesson lands softly, almost insultingly. Nothing here is built for speed. Not the doors, not the rules, not your hands. You thought the danger would be the pathogens. Wrong. The danger is you moving too fast in a place that punishes improvisation. You walk toward the first locked door, and the building answers you with a steady, mechanical exhale. Ventilation, constant and indifferent, like the lab is asleep but still breathing. Your badge meets the reader. There is a dull chirp, and the latch releases with a sigh you can feel through the handle. The corridor beyond is brighter, but not warm. Everything is scrubbed down to colors that do not invite emotion. Off-white walls, gray floors, stainless steel trims that reflect you in pieces. You are not a hero entering a battlefield. You are a pair of hands entering a system. You pass a sign with plain language that hides sharp teeth. Authorized personnel only. Follow posted procedures. Report all incidents. It is the lab version of do not touch the hot stove, except the stove can rewrite your life. Another badge check. Another door. And another, because safety is a series of small refusals. No, you cannot bring your coffee in. No, you cannot wear your favorite sweater. No, you cannot keep your phone. The lab does not care about your comfort. It cares about separation. This is how containment begins. Not with a vault door and dramatic lighting, but with layers. Layered access, layered documentation, layered expectations. You step through a little airlock vestibule, and the pressure shift is subtle but real. Your ears barely notice, but the building does. Here, air is not just air, it is an obedient employee. The boring truth is that most biosafety is architecture plus habits. Walls that are easy to clean, corners that do not trap grime, sinks that you can reach without touching a handle, a little foot pedal, a little sensor, a little engineering that assumes you will be tired and human. Somewhere deep in the building, there are freezers that never sleep. There are logs that never forgive. There are samples that represent old, ugly history, held in containers small enough to fit in your palm. And you are here tonight because human beings decided that the best way to survive a dangerous thing is to understand it, and then to lock it up, label it, track it, and never, ever get casual. You stop at a bench in an anteroom, an in-between space that feels like a confession booth. This is where you become a biosafety technician, not in the sense of earning a title, but in the sense of obeying a ritual. There is a checklist, of course. There is always a checklist, not because you are incompetent, but because your brain is a wet machine that lies. Memory is efficient, and efficiency is the enemy of careful work. You confirm your name, your date, your shift code. You confirm you are not sick, not coughing, not feverish, not pretending you are fine. It feels personal, but it is not. Even a mild cold can change how you touch your face, how you adjust your mask, how you focus. You inspect what you will wear, not like fashion, more like a mechanic checking brakes. No tears, no cracks, no weak seams. You check gloves for pinholes you will never see, but will always respect. You think this is overkill. It is not. A biosafety lab is a place where the most important events are too small to notice. A virus does not arrive like a monster. It arrives like dust, a particle, a smear you made with your sleeve while you were feeling confident. You read the posted procedures again, even if you have read them 100 times. That repetition is not punishment. It is training your nervous system to do the right thing when your mind wanders, because your mind will wander. It always does, especially during night shift when the building feels like a ship at sea. The hum of fans, the occasional click of a relay, the distant thump of an elevator you do not take. You open a locker that holds your street clothes hostage. You remove what the outside world brought in: watch, rings, jewelry, anything that can trap contaminants in little crevices. Your skin suddenly feels exposed, and that is appropriate. Then the first layer goes on. A simple inner garment, clean and dull, designed to be laundered hard. Next, dedicated shoes or shoe covers, because floors are honest about where you have been. Then comes the lab clothing, the barrier layer, a gown or coverall depending on the room you are entering. It rustles quietly, like paper pretending to be fabric. It is not armor. It is time. That is the first thing you learn about protective gear. It does not make you invincible. It makes you slower to contaminate and easier to clean. It turns catastrophe into a manageable procedure if you do not get arrogant. You pull on gloves, then another pair, because redundancy is the lab's love language. One glove is trust. 2 gloves is admission that trust is a bad plan. You tape seams where needed, not to be dramatic, but to remove gaps. Gaps are where nature negotiates its way in. A respirator or mask comes next, fit checked with small, practiced movements. You feel the seal against your face, and you do not adjust it again unless you must. Every unnecessary touch is a little coin tossed into the jar of risk. Some facilities use powered air systems with a hood and filtered airflow that whispers across your skin. When it works, it feels like standing in a gentle breeze that only you can feel. When it fails, alarms do not politely inform you. They complain loudly, because annoyance is a survival feature. You look at yourself in a mirror that is not there for vanity. It is there because humans cannot feel a loose strap behind the neck. You turn your head slowly, checking for gaps, checking for mistakes. This is where you begin to understand why most people would not last a day. Not because they are weak, because they hate this kind of deliberate slowness. People want to feel clever. They want shortcuts. They want to multitask. A biosafety lab wants none of that. It wants you to be a quiet machine with a boring soul. And here comes the part that surprises you. The routine starts to feel comforting. like a bedtime ritual. If your bedtime ritual involved double gloves and the documented chain of custody, each step has a place. Each motion has a reason. And because there is a reason, your mind can stop improvising stories. You check the door to the next room, and you wait for the indicator light. Green means stable, red means do not argue. You do not override, you do not negotiate, you do not become the main character. You enter, and the air feels different, though you cannot quite say why. Your skin does not feel it, but your ears notice a faint pressure. The room is not just a room, it is a direction. Airflow matters here, the way gravity matters outside. It is invisible, but it decides everything. The lab is designed so air moves from cleaner spaces toward dirtier spaces, then out through filters. Not because air is moral, but because physics can be bribed with fans and pressure differences. Negative pressure is the quiet trick. The room wants to pull air in, not push air out. So if there is a leak, the leak inhales instead of exhales. It is a simple concept that saves lives, mostly by preventing accidents from becoming travel plans. You walk past vents that look ordinary but behave like borders. Supply air comes in controlled and filtered. Exhaust air leaves in a way that assumes the worst. High-efficiency particulate air filters, the famous ones, sit in housings like silent guardians. They are not magic, but they are good at their job. Their fibers trap tiny particles through interception, impaction, and diffusion, which is a fancy way of saying the air takes a maze and loses its hitchhikers. Viruses themselves are tricky because they are smaller than many filters are rated for. But viruses rarely travel naked and proud, like lonely molecules. They travel in droplets, aerosols, bits of biological material, small rafts that filters can catch. And the rest is handled by layers again. Air changes per hour, directional flow, sealed surfaces, and the fact that you are not allowed to do risky procedures in the open room air. You pause and you listen. This is another habit that looks like superstition, but is actually maintenance. You learn the normal sounds so you can notice the wrong ones. A steady fan tone is comfort. A rattling vibration is a future incident report. A sudden hush is the kind of silence you do not want. The alarms, when they exist, are set to be slightly intolerable. Not terrifying, just persistent. Like a smoke detector with no respect for your feelings. You check gauges on a panel and you confirm numbers that represent invisible flows. Pressure differential within acceptable range. Filtration system operating. Door interlocks functioning. This is not because you doubt the system. It is because the system is made of parts, and parts have personalities. Belts wear, seals degrade, sensors drift. Trust is lovely, but verification is how you stay employed. You step deeper into the controlled space, toward the work area. Stainless steel counters, rounded edges, minimal clutter. Every surface is chosen because it can be cleaned and because it will not absorb what you fear. A biosafety cabinet sits there, humming softly. It looks like a glass-fronted box, not a throne. But in many labs, it is the real center of the universe. This is where you do work that could generate aerosols. This is where you open containers. This is where you pipette liquids that you do not want floating around in the room air. the cabinet breathes to. Just like the building, air is pulled in through the front opening, away from your face, and into the system. Inside, air passes through filters, maintaining a protective flow. Some cabinets protect the sample, some protect you. Some do both because life is complicated. You do not put your face inside. You do not wave your arms. You do not crowd the work area with unnecessary supplies. Turbulence is the enemy. If the airflow gets chaotic, the whole protective concept starts to behave like a suggestion. You arrange what you need inside slowly in a layout you have practiced. Clean items on one side, potentially contaminated items on the other. A mental map that prevents your hands from crossing lines while your mind is halfway asleep. This is where the job becomes almost meditative. Your hands move in a narrow choreography. Pick up, open, transfer, close, wipe, place. And the reason it feels calm is because you are doing fewer things, not more. You are reducing freedom. Freedom is where accidents hide. You look at a set of tools that all share one feature. They are easy to disinfect, smooth handles, minimal seams, disposable tips, no porous wood, no fabric, no friendly textures. In a normal kitchen, you might chop vegetables on a wooden board. Here, wood is a sponge with ambitions. It would love to keep secrets. You pick up a pipette, and the motion is tiny. Your thumb presses with controlled pressure. You do not snap, you do not flick, you do not create a mist because you were impatient. Aerosols are the quiet problem. They are what happens when you treat liquids like they are obedient. A droplet the size of a whisper can carry enough virus to ruin a month. You practice keeping the tip close to the liquid surface. You dispense along the side of a tube, not into open air. You cap tubes immediately, because open containers are not containers. They are invitations. You wipe surfaces with disinfectant in the same direction, with the same contact time every time. Disinfectants are not instant. They are not a magic spell you cast with a quick swipe. They need time to work, because chemistry is slow and petty. Some agents disrupt lipid envelopes, making certain viruses fragile. Others denature proteins, unzipping the machinery. Some are oxidizers, ripping electrons away like thieves in an alley. And some microbes do not care as much as you would like. Spores, for example, are nature's way of putting life in a vault. They are dry, tough, and stubborn, like a bad idea that survived winter. Smallpox, the one everyone whispers about, is not a spore former. It is a virus, specifically variola virus, an orthopox virus, a real piece of ancient human misery with a neat geometric shell. You do not handle it casually, even in a story. In reality, access to variola virus is extremely restricted, held in only a couple of designated repositories under heavy international oversight. And that is the point. If something is dangerous enough, the world tries to agree, reluctantly, on where it can exist. Your job, in the broad sense, is not to be brave around these agents. It is to make bravery unnecessary. You glance at labels and you feel the weight of how boring they are. Sample identifier, date, initials, storage location, hazard category. No poetry, no drama, just information that prevents confusion. Because confusion is a hazard. A mislabeled tube is not a mistake, It is a branching path into chaos. If you do not know what you are holding, you cannot choose the right disinfectant. You cannot choose the right containment. You cannot choose the right response. You learn quickly that biosafety is not just about the pathogen. It is also about the paperwork, the inventory logs, the access records, the training certifications, all the dull things that keep dangerous materials from becoming lost property. In movies, the villain steals a vial in a pocket. In real life, a vial has a chain of custody. It has barcodes, signatures, dual verification, and a freezer that complains if it warms by a few degrees. The laboratory is designed to make theft inconvenient and mistakes trackable, not because it assumes you are evil, but because it assumes you are human. And humans forget, misplace, and rationalize. You are reminded, gently, that your worst enemy is fatigue. Night shift makes the mind float. You can stare at a label and see what you expect to see. That is why the lab makes you read it out loud sometimes, or have a second person confirm. You place items in secondary containment, which is a fancy term for a sealed container inside another sealed container. Like putting a letter in an envelope, then putting the envelope in a box, then locking the box, then writing a log about it. Excessive, yes. Also, effective. Your hands hover over a small sealed tube and you feel a ridiculous thought. It is so small, you could lose it under a fingernail. And yet, entire policies, entire architectures, entire careers are built to keep it from touching the wrong skin. That is what modern biosafety is, taking something that could be catastrophic and reducing its opportunities to move. You learn to separate zones, even within the cabinet. A clean side, where sterile supplies live. A working side, where samples are manipulated. A waste side, where contaminated disposables go to wait for sterilization. The separation is not about morality. It is about probability. If your clean glove touches your dirty waste bag, your clean glove is now a liar. So you work as if every touch leaves a trace. Because it does. Contamination is not a cinematic splash. It is a fingerprint, a smear on a tube cap, a droplet on a sleeve cuff, a touch to your goggles, because they itch, and you do get itchy. Because humans are built to be inconvenient. Your nose will decide to tickle at the worst time. Your eye will want to blink hard. Your face will demand attention, like a toddler. You learn the skill of noticing the impulse and not obeying it. You learn to step back, remove outer gloves properly, sanitize, adjust, re-glove, and return. It is slower, but it is safe. You also learn that the lab is designed to make the safe choice easier than the unsafe one. Hand sanitizer is placed where your hands naturally pass. Waste containers are foot-operated. Sharps containers are within reach, so you do not walk across the room holding a needle like an idiot. Yes, needles happen. Not always, but often enough that everyone has a story. A needle stick injury is a small puncture with a huge shadow. So procedures are built to avoid needles when possible and to control them when not. You never recap by hand. You never leave sharps lying around. You never pretend you will remember, because you will not. The lab trains you to behave like a cautious animal. Minimal movement, clear territory boundaries, predictable routines, the kind of behavior that keeps you alive in a world full of teeth. And the strange thing is, the longer you do it, the more it becomes quiet, not empty quiet. Like a room where everything has a place and nothing is asking you to solve it. You check your work surface again. You disinfect. You wait the proper contact time. You wipe again. You dispose of materials in the correct stream. Biohazard waste is not just trash. It is a promise to treat it before it leaves the controlled environment. Autoclaving is one common method, using pressurized steam to denature proteins and wreck membranes. It is not glamorous, but it is thorough. Heat plus moisture, applied long enough, is one of the oldest ways to make biology stop being ambitious. The autoclave is basically a steel lecture to microbes, a loud one. You hear it sometimes in the background of the facility. A low rumble, a venting hiss, like the building clearing its throat. Another reminder that the lab is always doing something, even when you are not. You look back to the cabinet and you notice how your movements have slowed. Your shoulders are lower. Your hands are steady. Your thoughts are narrower, not scattered. This is the paradox of high containment work. If you do it right, it feels almost boring, because boredom is the absence of surprise. Surprise is what you are preventing. And speaking of surprise, you start to learn how contamination really happens. Not through dramatic explosions, but through small, ordinary behaviors that sneak in when you are tired. A sleeve brushes a bench edge. A gloved finger taps a pen. The pen goes into your pocket. The pocket goes home. Congratulations, you invented a very stupid delivery system. So you keep lab pens in the lab. You keep notebooks in designated areas. You label everything clearly, because an unlabeled tube becomes a mystery, and mysteries are expensive. You never mouth pipette. Yes, people used to do that. Yes, it was as bad an idea as it sounds. It is how you end up tasting the problem. The lab does not want you tasting anything, ever. So you treat your mouth as an exit only, not an entry. And you keep your hands away from your face like you are dealing with an invisible pepper spray. In training, they sometimes show you fluorescent dye simulations, a harmless, glowing marker placed on a surface, then tracked under ultraviolet light. It looks like a magic trick until you realize the glow is everywhere you touched. Door handles, keyboard keys, sleeves, cheek somehow. The dye becomes a map of your unconscious habits, and it is always worse than you expect. That is why the lab is obsessed with doffing procedures, the careful removal of protective gear, because the outside of your gloves and gown may be contaminated, even if you never saw a spill. So you learn sequences: outer gloves off without snapping, hand hygiene, gown rolled inward to trap the outer surface, hand hygiene again, face protection removed by straps, never by the front, and again, hand hygiene. Because the lab is not subtle. The habit is not about fear. It is about acknowledging that biology is opportunistic. Smallpox historically spread through close contact and through contaminated materials like bedding and clothing, because the virus can persist in scabs and dried material for a time. It is not a ghost, but it is stubborn enough to earn respect. In a lab, you assume that any surface could host a trace, and you build your routine accordingly. That assumption is not paranoia. It is the foundation of biosafety culture. You feel the pressure of it sometimes, the way it keeps you from drifting. You cannot daydream with your hands. You can daydream with your mind, maybe, but your hands must stay loyal to the procedure. And if your mind forgets, the checklists catch you. The labels catch you. The training catches you. Most of the time, nothing happens. And that is not a lack of excitement. That is success. You finish a small set of manipulations, close the last container, and wipe it down before it leaves the cabinet. Then, you place it into a secondary container, sealed, labeled, and dull. A sample is a strange thing. It is a tiny physical object, but it carries a whole story. Where it came from, what it contains, what it could do, who is allowed to touch it. You log the movement because in a lab like this, objects do not teleport. They travel with documentation. Your eyes move to the clock, not because you are bored, but because timing matters. Contact times, incubation times, sterilization cycles, even the building's pressure checks are timed, scheduled, tracked. There is a rhythm here, a slow metronome of procedures, and you begin to understand the title you were warned about, why you would not last a day. Not because the work is physically impossible, but because it demands a kind of patience that feels unnatural in a world built for speed. The modern world teaches you to swipe, skip, and optimize. This place teaches you to pause, confirm, and repeat. The lab does not reward cleverness. It rewards consistency. You take one more look at your workstation, checking for clutter, checking for anything out of place, because out of place is where accidents begin. A tube left uncapped, a wipe left drying, a label half stuck. You correct tiny things with the seriousness of someone defusing a bomb made of paperwork and proteins. And as you prepare to move forward in the shift, there is a gentle pivot waiting for you. Because once you are inside all these layers, once the building is breathing correctly, the most important variable left is still you and what your hands decide to do next. So you let your hands decide, and your hands decide to do less. You bring only what you need into the cabinet, nothing extra, nothing sentimental. A sterile tube rack that feels too light to matter. A handful of sealed tips that click into place like tiny plastic teeth. A marker that lives here and will die here, never leaving this room. You think the danger is in the sample, but the danger is in the choreography, the little arcs your wrists make, the way you reach over something instead of around it, the way you forget for half a second which side is clean. So you build borders, not dramatic borders with fences and spotlights. Boring borders, tape lines, tray edges, a habit of placing everything at right angles. It looks obsessive until you realize obsession is cheaper than an exposure report. Inside the cabinet, the air is moving with quiet authority. You cannot see it, but you behave like you can. You keep your hands low and steady, because high, fast movement makes turbulence. Turbulence is what happens when air stops being obedient. You keep your forearms from blocking vents. You do not drape paper towels where they should not be. You do not let a sleeve flap into the airflow like a flag of bad decisions. You learn to respect the cabinet's invisible geometry. This is the art of not spilling anything, even when the volume is tiny, even when it looks harmless, even when you feel confident, because confidence is how you get sloppy, and sloppy is how a droplet becomes a story. You pick up a tube with two gloved fingers. Like you, are holding a sleeping insect. You crack the cap slowly, not to be gentle, but to avoid pressure pops. The cap makes a small sound, a soft plastic complaint. You keep it angled, away from your face, away from the cabinet opening. It is a silly thing to say, but you treat air like a surface. If you flick liquid into it, it does not forgive you. It just carries your mistake around until a filter catches it, or you do. You pipette with the kind of patience that would ruin you in any other job. You pre-wet the tip, aspirate smoothly, dispense against the tube wall, no splashing, no bubbling, no foamy enthusiasm. Bubbles are not cute in here. Bubbles mean aerosols, tiny droplets breaking free like commuters leaving a train. And you do not want commuters. You keep a little waste container inside the cabinet, lined and ready. Anything disposable goes in without ceremony. No piling things up to deal with later. Later is when your elbow bumps the pile, and gravity gets involved. Gravity is not your friend, by the way. It is loyal only to mass and distance. It will pull a contaminated tip onto your sleeve with the same enthusiasm it pulls apples. So you do not give it opportunities. There is a calm pleasure in how dull this becomes. Pick up, open, transfer, close, wipe, place. A loop, a ritual, a tiny mechanical prayer, repeated until it stops feeling like effort. And you notice something else. Your hands start to learn without your brain. Muscle memory builds a quiet fence around your mistakes. Your fingers stop hovering over forbidden surfaces. Your thumbs stop searching for the quickest route. This is why training spends so much time on motions. Not because anyone loves telling you what to do, because under stress, you will not rise to your ideals. You will fall to your habits, and the lab would prefer you fall gently. You reach for a disinfectant wipe, and you do not scrub like you are angry. Anger makes splatter. You wipe with deliberate strokes, one direction, overlapping passes. You leave the surface wet, and you let chemistry do its slow work. Contact time is the part people hate. You want to wipe and move on like wiping a kitchen counter. But disinfectants are not magic. They are molecules with jobs. They need minutes, not wishes. Some disinfectants attack lipid membranes. That is good for many enveloped viruses, the ones wearing a fatty coat. Other agents denature proteins, folding them wrong until they stop functioning. Oxidizers steal electrons, turning biological structures brittle and broken. And then there are organisms that do not care enough. Bacterial spores, for example, are nature's way of saying, try harder. They are dry, armored, and patient, like a problem you thought you solved. So the lab chooses disinfectants like a chef choosing knives, specific to the job, specific to the target, always checked for expiration dates. Yes, expiration dates, even for chemicals that smell like a swimming pool's hatred. You glance at the label on the bottle, and you notice the quiet details. Active ingredient, concentration, lot number, prepared date. Someone made this solution, someone signed for it, someone will remake it on schedule. Because a disinfectant that is too weak is just scented water with confidence issues. Your hands move again, and you pick up a small sealed container. Not because it looks special, but because everything in here is treated the same. In high containment, you do not rank danger by vibes. You place the container into a rack, and the rack into a tray. Secondary containment is not paranoia. It is a philosophy. Assume the first barrier will fail eventually. Plan so the second barrier makes that failure boring. Boring is the goal, always. Boring means controllable. And as you work, you keep one eye on something humans hate admitting exists. Your own clumsiness. Your glove can snag. Your sleeve can brush the cabinet edge. Your grip can slip when you are tired. So you design movements that still work even if you are imperfect. You hold tubes over absorbent pads, not open air. You open caps slowly, not with a snap. You keep liquids low, close to surfaces, like you are carrying a full mug in the dark. You might think this is all about fear. It is not. It is about probability. Risk is not a monster. Risk is math wearing a lab coat. It is the number of chances you give a bad outcome to happen. So you reduce chances. That is the whole job in its simplest form. There is a small sound from outside the cabinet, a cartwheel shifting, a distant door seal sighing shut. The building is always adjusting itself, like a living thing trying to maintain posture. You hear the steady fan tone again, and you take comfort in it. Not because fans are comforting, but because normal sounds mean systems are normal. You never want to discover silence. You finish a set of transfers and pause, hands held still. This is another habit, the pause. You stop before you move to the next step, and you confirm where everything is. Open container, closed container, waste, clean supplies, your hands. It is like counting your fingers after you have been using a saw. Not because you expect to lose one, but because you respect the tool. And then you do something that looks absurdly ordinary. You label. It is just ink on plastic, but it is the difference between science and chaos. Identifier, date, initials, hazard marking, storage location code. Your handwriting is careful and ugly, the way it should be, because pretty handwriting can be misread, and misread labels become wrong assumptions, and wrong assumptions become wrong disinfectants, wrong containment, wrong reactions. You think about how many disasters start with someone thinking, "I will remember." Congratulations, you will not. So the lab externalizes memory. Labels remember for you. Logs remember for you. Two-person checks remember for you. Because your brain is not a vault, it is a rumor mill. You place the labeled tube into a sealed bag, then into a rigid container. You wipe the outer surface. You set it aside in a designated spot. Not in the middle, not near the edge. Everything has a home, because wandering objects are how contamination travels. A tube placed casually becomes a tube bumped later. A glove laid down becomes a glove picked up wrong. A cap set aside becomes a cap that rolls. Rolling objects are comedy in normal life. In here, they are paperwork and regret. You feel the rhythm settle in. Your hands know where to go. The cabinet hum becomes a lullaby for cautious people. And you realize the lab is not asking you to be fearless. It is asking you to be predictable. That is why you practice simple motions. Twist caps the same way every time. Hold tubes at the same angle. Dispose tips immediately. Do not improvise. Improvisation is for jazz, not pathogens. And speaking of pathogens, there is an invisible passenger you are always thinking about, even if you pretend not to. Not the virus itself, not as a tiny demon, but the way it moves. It moves through droplets, through smears, through fingertips. It moves through your habits. So you learn to treat your hands like they are always telling a story. Every contact is a sentence. Every surface you touch becomes part of the plot. You look at the cabinet's front grille, the intake where air disappears. It is quietly hungry, pulling air inward, protecting you from whatever wants to drift out. You keep objects from blocking it, because blocking it changes the flow. If you block the flow, the cabinet still hums. It still looks like it is working. And that is the problem. Failures are often quiet. You learn to respect quiet failures more than loud ones. A loud alarm is honest. A quiet mistake is stealthy. You complete your task batch and begin the gentle undoing. Work surfaces disinfected, tools wiped and placed into the correct containers, waste sealed for decontamination, and you do not rush the cleanup, because cleanup is not the end. Cleanup is when people get hurt. The task feels done. The brain relaxes. The hands speed up. That is when a glove snaps. That is when a cap flicks. That is when a sleeve brushes something you forgot existed. So you keep your pace, slow, even, a little dull. You remove the outer gloves inside the cabinet, peeling them off without snapping. You drop them into waste with controlled movements. You sanitize the inner gloves because the lab loves redundancy like it loves paperwork. Then you wait, not in a dramatic way, just long enough for the disinfectant to do what you paid it to do. You step back from the cabinet and take stock of the room. Counters are clean, floors are clear, waste is contained, samples are secured. Nothing is on the edge of anything. Edges are where accidents live. And now, because humans are wonderfully imperfect, you spend a moment thinking about all the ways contamination actually happens. Not the cinematic ways, the boring ways. It happens when you touch your face. It happens when you adjust your glasses. It happens when you scratch your cheek through a hood, convincing yourself it does not count. It happens when you handle your phone with gloves. Yes, someone has done it. Yes, it was as stupid as it sounds. It happens when you bring a notebook too close to the work zone. Paper is porous, thirsty, and eager to absorb whatever you spill. It is a terrible surface, which is why lab notebooks are treated carefully, sometimes even kept behind barriers. It happens when you forget that sleeves exist. A sleeve drags across a bench, and later, your sleeve drags across a chair. And then you sit. Congratulations, you invented a transfer route using fabric and denial. It happens when you set down a pen. A pen touched with gloves becomes a pen that lives in the lab. If you pocket it, you are smuggling microbes like a bored teenager stealing candy. It happens when you confuse clean and dirty zones. You step across a line without thinking. You place a clean tube on a dirty tray. You touch a door handle with contaminated gloves because your mind was already in the next room. So the lab tries to make the safe choice the easiest choice. Hands-free sinks, foot pedals, doors that open with elbows, waste bins that are always within reach. It is not because anyone thinks you are evil. It is because everyone knows you are tired. Night shift fatigue is a special kind of slow poison. It makes you feel normal while your attention frays. It makes you sure you read the label correctly when you did not. It makes you confident that you tightened the cap when you only imagined it. So procedures become rails. You do not rely on your feelings. You rely on steps. Read the label. Say it out loud. If you have to, check the identifier. Check the date. Check the destination. Close the container immediately. Do not set it down open, even for a second. Even for a second is how air gets invited. And then there is the one contamination pathway that always feels unfair. Aerosols you never see. You can work perfectly and still create them if you are careless with pressure. If you expel liquid too fast, if you vortex a tube without sealing it correctly, if you open a container that has built pressure inside, some procedures are notorious. Centrifugation, for example, can be a beautiful way to make tiny particles separate. It can also be a beautiful way to make a tiny leak become a mist if a tube fails. So centrifuges in containment labs are treated with suspicion. Sealed rotors, safety cups, careful balancing, waiting time after a run so aerosols can settle before you open anything. You do not pop the lid like a kid opening a snack. You let it sit. You let the cabinet airflow catch what it can. You behave like the air is full of invisible glitter that you do not want on you. In training, they show you fluorescent dye under ultraviolet light. It always looks like a crime scene. The dye starts on a single handle, a single glove fingertip. Then it appears on the keyboard, the chair, the door, the sink, and somehow, mysteriously, on the face shield. It is never magic. It is habit. So you become a student of your own unconscious movements. You learn what your hands do when you think no one is watching, because the pathogen is always watching in its own indifferent way. It does not hate you. It does not love you. It just uses whatever route exists. And now, with all that in mind, you keep working until the moment the lab eventually forces you to practice the thing everyone pretends will not happen. The moment something goes wrong. It is not dramatic. It is not a slow motion crash with music. It is often a small sound, a click you did not expect. A tube slips. It taps the cabinet surface. For a fraction of a second, it looks fine. Then you see it. A bead of liquid, glossy under the cabinet light, spreading like a lazy eye. Not a flood, just enough to matter. Your body wants to jerk back. That is what humans do. But jerking back is how you make airflow chaotic. Jerking back is how you bump other things. So you do the opposite of instinct. You freeze. Then you move slowly. You keep your hands inside the cabinet. You keep your breathing steady behind the mask. You do not curse, even though you want to. A spill is not a moral failure. It is a procedure. You alert the room according to protocol. If you are alone, you speak anyway, because speaking keeps you on script. Small spill in cabinet, contained, initiating cleanup. Then you let the disinfectant do what disinfectant does. You cover the spill with absorbent material, gently laying it down instead of dropping it. Dropping makes splatter. You apply disinfectant from the outside in. Outside in, because you do not want to push contamination outward. You soak the absorbent material until it is saturated. Then you wait. Waiting is the hardest part for people who want control. But in biosafety, control often means letting time pass. The chemical needs time to penetrate. It needs time to disrupt proteins, membranes, genetic material. It needs time to turn living ambition into inert debris. So you stand there, hands still, while minutes crawl. And you notice how strange it is that the response to danger is often stillness. When the contact time is complete, you wipe up slowly. Everything goes into biohazard waste. You disinfect again. You check the surrounding surfaces. You check your gloves. If there is any doubt, you change them. And you document it. That is the part people hate almost as much as waiting. You write what happened, when, where, what you did, what disinfectant, what contact time. You do not rely on memory. You do not smooth the story to make yourself look better. Because incident reports are not punishment. They are data. They are how the lab learns where procedures need improvement. They are how the next person avoids your mistake. A mature safety culture does not pretend accidents never happen. It assumes they will eventually, and it builds calm responses that work at 2 in the morning. Sometimes the wrong thing is not a spill, but an alarm, a pressure differential alert. For example, a little beep that keeps beeping. Not screaming, just nagging, like a smoke detector with a personality. You do not ignore it. You do not assume it will stop. You check the panel. Maybe a door is not sealed fully. Maybe someone propped something open by accident. Maybe a filter housing is reporting a change. Often, it is something simple. A door not latched. A gasket needing adjustment. A sensor that drifted. But you treat it seriously because the whole building's promise is directional airflow. If airflow becomes confused, containment becomes a suggestion. So you follow the protocol. You stop work. You secure samples. You close containers. You ensure the cabinet is safe. You notify the right people, facilities, safety officer, supervisor on call. The lab is not a lone hero story. It is a network. And you wait again, in that familiar way. Not passive, just patient. If the issue is resolved, you resume. If it is not, you exit according to procedure. Because sometimes the safest thing you can do is leave. Leaving is underrated. People like to imagine bravery as staying. But in a high containment lab, bravery is often walking away from unfinished work. The lab will still be here tomorrow. Your pride is not worth a breach. And when you finally finish the task cycle, after a small incident, there is a strange satisfaction. Not because something went wrong, but because the response was boring. Boring means the system worked. Boring means the incident did not become a headline. You secure the samples again, and that brings you to the part of the job that feels almost ceremonial. Turning living risk into quiet, labeled information. The sample itself is unimpressive. A small vial, a tube, a sealed bag with a barcode. You could hold it between finger and thumb, but you do not casually. You hold it like it weighs 1,000 pounds, because it does, in consequences. You check the label again. You compare it to the log. 2 independent identifiers, because humans love confusion. You verify the chain of custody. Who handled it last, when it moved, where it is going. Nothing moves without a paper trail or an electronic one, depending on the facility. A chain of custody is not romance. It is accountability. You place the sample into a transport container designed to survive stupidity. Sealed, rigid, sometimes with absorbent padding. sometimes with tamper evidence. The container is a small coffin for uncertainty. Then you move through the lab with controlled steps. No rushing, no shortcuts, no sudden turns. You do not carry samples pressed to your chest. You carry them away from your body in secondary containment, because if you trip, you want the container to hit the floor, not your rib cage. Trip hazards are handled aggressively in these places. Cords are managed. Floors are kept clear. Even so, you remain aware that your own feet are always plodding. You arrive at storage, and storage is almost offensively dull. A freezer with a lock, a log sheet, a temperature display. Sometimes an alarm system that texts people who would rather be asleep. Inside the freezer, racks and boxes are organized like a library. Not because organization is satisfying, but because searching is dangerous. You do not want to dig through a freezer with gloved hands, moving boxes around, letting frost build up. You do not want to warm things unnecessarily. You do not want to lose track of where your sample is. So, everything has a location code: shelf, rack, row, box, position. It is geography for tiny threats. You open the freezer briefly. Cold air spills out, dry and sharp, like winter exhaling. Your gloves feel stiff for a moment. You place the sample into its assigned slot. You close the freezer. You lock it. You log the movement immediately. This is one of those moments where you realize what the job really is. Not handling pathogens, handling human error. Because the pathogens do not sign forms. They do not misread labels. They do not skip steps because they are bored. You do. So the system wraps you in redundancy until your mistakes become unlikely. And now, because you are human, your mind wanders to the name people whisper: Smallpox, not as a lab specimen, not as a movie villain, but as a shadow in human memory. You have read about it, of course. Everyone has, in a way, even if they do not realize. Old photographs, pitted faces, historical accounts that sound unreal because they are too brutal. Smallpox was not just a sickness. It was a long-term roommate of humanity, the kind that eats your food and then burns down the kitchen. It spread through close contact, breath, droplets, direct touch. It loved crowded rooms and family gatherings. It turned ordinary intimacy into risk, and it left marks. Not metaphorical marks, physical scars, pockmarks, blindness, survival with a receipt printed on your skin. The virus itself, variola, is an orthopoxvirus, a large virus, as viruses go, with a complex structure, not alive in the way a bacterium is alive, but efficient at hijacking cells. It carries genetic instructions, and it carries proteins that help it evade the immune system. It enters through the respiratory tract often. It finds cells, and it persuades them to make more virus. The incubation period is long enough to be cruel, often about a week and more. Quiet at first. You feel fine, you go to work, you touch doorknobs, you hug people. Then the fever hits. Deep fatigue, headache, back pain, sometimes vomiting. Your body announces something is wrong before it tells you what. Then comes the rash. And the rash is not just a rash. It progresses in stages: maculus, papulus, vesicles, pustules. Flat spots become raised bumps, then fluid-filled blisters, then pus-filled lesions. They tend to be more concentrated on the face and extremities than chickenpox. They evolve together in the same area, more synchronized. It is one of the clinical clues that used to matter. Back when doctors saw this in real life, the lesions scab over, then fall off. And in those scabs, the virus can persist for a time, protected in dried material. That is why bedding and clothing could carry danger. Imagine trying to do laundry in that world. Imagine sleeping in a house where the sheets are a hazard. The death rate depended on the form of the disease and the population. Variola major was often around 30% fatal in unvaccinated populations, sometimes higher. Variola minor was less lethal, but still miserable, and survivors were not untouched. Scarring, blindness from corneal involvement, secondary infections. The immune system would win, sometimes, but it paid. This is the part where people like to say, "At least we defeated it." And yes, humans did something rare here. Eradication. Not elimination in one country, not control, but global eradication. No natural cases. It happened because of vaccination, surveillance, and a stubborn logistical campaign that was more paperwork than heroism. Ring vaccination, in particular, targeting contacts of cases, building immunological firebreaks. Vaccination for smallpox used vaccinia virus, a related orthopox virus. It trained the immune system without exposing people to variola itself. The vaccine left a characteristic scar on the upper arm, a small circular reminder of controlled infection. It is strange to think about using a virus to teach the body to fight a virus. Biology teaching biology, like a knife sharpening another knife. And it worked, because smallpox had features that made it eradicable. No animal reservoir, mostly. A visible disease, so cases could be recognized. A vaccine that provided strong protection. Eradication was declared in the late 1970s. One of the few times humanity collectively did a hard thing and finished it. And yet, the samples remain, locked away. Officially, variola virus is kept in only a couple of high-security laboratories under international agreement. The argument is that research might be needed for antivirals, vaccines, diagnostics. The counter-argument is that keeping it at all is a risk. You do not solve that debate at 2 in the morning. You just live inside the reality it created. In the lab, fear is translated into structure. If something is dangerous, it is controlled by layers, by access restrictions, by oversight, by audits. You cannot just wander into a room containing variola. You cannot just decide to run an experiment. The permissions are heavy, the procedures strict, the scrutiny intense. That is what it means when people say it is restricted. Not just locked, monitored, justified, accounted for. And you, as a biosafety technician in this story, are part of that accounting. Not a hero, a ledger with hands. Your job is to make sure the world never has to remember smallpox the hard way again. But smallpox is only the famous ghost. The lab deals with other threats too. Quieter ones, less cinematic, still hungry. Influenza, for example, has the charm of constant change. It mutates, reassorts, drifts, shifts. It treats immunity like a puzzle to be solved again every year. You have heard people call it just the flu. That phrase has killed people. Influenza viruses have segmented genomes, meaning their genetic material comes in pieces. If 2 strains infect the same cell, those pieces can shuffle, creating a new combination. That is antigenic shift. the kind that can contribute to pandemics. Antigenic drift is smaller change over time, mutations accumulating, enough to evade prior immunity. That is why vaccines are updated, why surveillance matters, why nature does not let us get comfortable. Then there are bacteria that learn to laugh at antibiotics. Methicillin-resistant Staphylococcus aureus, for example, a skin bacterium turned opportunist. Carbapenem-resistant Enterobacteriaceae, organisms that carry enzymes to destroy last resort drugs. These are not exotic jungle diseases. They can live in hospitals, on surfaces, in plumbing. They are the everyday monsters born from selection pressure and human overuse of antibiotics. Microbes reproduce fast. They mutate. They exchange genes. Plasmids move resistance traits like trading cards. If you want an image, imagine a crowded marketplace where bacteria swap little rings of genetic code. A gene for resistance here, a pump protein there. Nature running a business meeting. And the lab's role is often not to fight these organisms directly. It is to understand them, track them, test them, create boundaries. You may handle samples from patients, from animal surveillance, from environmental monitoring. You may process cultures, run polymerase chain reaction tests, sequence genomes. Polymerase chain reaction, by the way, is basically a molecular photocopier. It takes a target genetic sequence and amplifies it so you can detect it. It is powerful, sensitive, and extremely easy to contaminate. So even in lower containment settings, polymerase chain reaction labs have their own obsession with clean and dirty zones, pre-amplification and post-amplification, separated. Aerosol-resistant tips, dedicated pipettes, because one stray molecule of amplified product can give you a false positive, and false positives cause panic, wasted resources, wrong decisions. So again, the enemy is not just the microbe, it is your habits. Sometimes the hazards are carried by insects. Arboviruses, viruses transmitted by arthropods like mosquitoes and ticks. Dengue, Zika, yellow fever, West Nile. You cannot see the virus in the mosquito. The mosquito just wants blood for egg development. It is not malicious, just biologically compelled. But the virus uses that behavior like a bus route, blood meal, saliva, transmission, a tiny injection you barely feel. In labs that handle these agents, sometimes there are insectaries, controlled rooms for mosquitoes. That idea makes people uncomfortable, and it should, because you learn quickly that containment is not just about tubes and filters. It is about living animals, sometimes. If you work with infected animals, the complexity increases. Animals bite, scratch, urinate, shed hair, and dander. They do not read your protocol, so you use specialized caging, directional airflow, careful handling. You sedate when necessary. You protect yourself from sharps and teeth, and you respect the ethical weight of it, because science, as presented to the public, is clean and triumphant. Science, as practiced, is messy and full of compromises. You do not get heroic music. You get the sound of bedding being changed, the smell of disinfectant, the constant attention to waste streams. Waste streams are their own quiet universe. Solid biohazard waste, liquid waste treated chemically, sharps in puncture-resistant containers, carcasses handled according to protocol. Everything is tracked because everything could carry something. The goal is rarely drama. It is preventing small outbreaks from becoming big ones. That is what biosafety teams do. They negotiate boundaries with nature. They do not defeat nature. They do not conquer microbes. Microbes will outlast us. They were here long before, and they will be here after, unless the universe ends first. You simply build walls and habits and systems that keep microbes in their lane, in the lab, in the sample, in the data, not in your lungs. And while you are doing all this, night shift continues its slow crawl. The building stays awake in its mechanical way. The fans hum. The gauges remain steady. You check the time and realize how many hours you have been moving like this. How many decisions your hands have made correctly. How many chances you have refused to give the universe. This is the hidden labor of biosafety. It is not one big act of courage. It is 1,000 small acts of restraint. And eventually, you reach the part of the shift where the work winds down. Not because the risk disappears, but because you have done what you came to do. Now, the last big task is the one people underestimate: leaving. Leaving without bringing anything with you. Because the lab does not end at the cabinet. It ends when you are back in ordinary air with ordinary hands and nothing invisible hitchhiking on your skin. So you begin decontamination, the careful unlayering. You move to the doffing area, a space designed for removal. Chairs positioned to avoid tipping. Mirrors to help you see straps. Waste bins placed at the perfect distance so you do not reach awkwardly. Even the furniture is part of the protocol. You start with the dirtiest outer layer. Outer gloves first, peeled away slowly, turned inside out. No snapping. Snapping makes droplets. Hand hygiene. Again, the lab loves hand hygiene like it loves documentation. Then the gown or coverall is removed in a controlled roll, folding the contaminated outside inward. You avoid flapping it like laundry. Laundry is a wonderful way to aerosolize your problems. You drop it into designated waste or into a container for sterilization, depending on the facility. Some things are disposable, some things are reusable, and autoclaving is pressurized steam, hot and wet and thorough. It is one of the few ways to make even stubborn biology stop being ambitious. Then face protection comes off by the straps, never by the front. The front is where anything would land. You remove it like you are handling a dirty plate, not touching the food side. Hand hygiene again. Respirator removal is careful too. Straps, not the mask surface. Slow movements, because tired hands love to rush. If the facility uses powered air systems, there are specific steps: disconnecting hoses, parking the hood, wiping surfaces. The equipment is treated like a colleague who did its job and now needs to be cleaned. You check yourself in the mirror. Not vanity, verification. Any visible contamination would trigger additional steps. In some facilities, there are showers out, full-body decontamination before exiting. Not always, but sometimes, depending on agent and level. And through it all, the mood stays annoyingly calm. That is the point. Panic makes mistakes. Calm makes steps. When you finish the doffing sequence, the air on your face feels different. Not cleaner exactly, just less mediated. The hallway outside the controlled area feels soft, like the building loosened its grip. The lights are a little warmer. The hum is still there, but less intimate. You sign out because even leaving is logged. Time out, condition check, any incidents, any notes for the next shift. Then you step into the changing area and retrieve your street clothes. You put your watch back on, your ring, your small human accessories. It feels like re-entering civilization after pretending to be a machine. And this is the part people outside the lab rarely think about. Most of the protection they benefit from is invisible and boring. They do not see the checklists. They do not see the double gloves. They do not see the contact times, the logs, the alarms that kept annoying someone into paying attention. They just live in a world where outbreaks are sometimes detected early, where a lab result is trustworthy, where a sample did not escape into a hallway. You walk toward the final exit, and the outside air smells full. Not filtered dryness, but the complicated scent of the world. Dust, detergent, faint food from a vending machine, the ghost of someone's perfume. It is ordinary air, and ordinary air is a luxury. You step out into the night or early morning, and nothing about you looks heroic. No blood, no battle damage, no dramatic music. Just a person who spent hours doing everything slowly, on purpose. Survival often looks like patience, not bravery. And patience, it turns out, is a skill you can practice until it becomes a personality. But even as you leave the building behind, your mind keeps wandering. Because once you have spent a shift negotiating boundaries with microbes, you start noticing other invisible systems, other quiet forces working while you sleep, other machinery keeping you alive without asking permission. And one of them is already inside you. Moving through you right now, a private logistics network of vessels and pressure and cells, delivering oxygen like it is running a night shift of its own. Because speaking of containment, speaking of borders, speaking of what happens when a tiny leak becomes a disaster, you carry an entire biosafety problem in your chest every time your heart decides to beat. The funny thing is, you do not notice that internal containment system until it misbehaves. When it works, it feels like nothing at all, which is how your body sells you the illusion of safety. You think you are just lying there, warm, still, protected by blankets. Wrong. You are a wet ecosystem under pressure, and the borders are constantly enforced. You are about to shrink down, past skin and fat and polite anatomy diagrams, and you are going to become a single red blood cell. Erythrocyte, if you want the proper name. A soft, flexible disc built to carry oxygen. Human translation? You are a delivery truck with no steering wheel. You are released into a vein like cargo, dumped onto a moving belt. The world around you is dark, not black, but deep red-brown, like tea that has been brewing too long. There is no air here, no breathing, no comforting inhale, just warm fluid pressure and the constant shove of the current. You might imagine your bloodstream as a clean highway system, smooth walls, orderly lanes, calm traffic. But the inside of a living vessel is not stainless steel. It is tissue, alive, reactive, slightly irritated by existence, and always one bad day away from inflammation. The vessel wall is lined with endothelium, a thin living skin that tries to act like a nonstick pan. Most of the time it succeeds. It releases molecules that tell platelets to stay calm. It manages the squeeze and relax of the vessel like a quiet bureaucrat. And it does all this while you, the red blood cell, slam into turns at every branch. You drift in laminar flow when things are going well. That means the blood layers slide past each other in smooth sheets. The fastest flow is in the center. Near the walls, the flow slows, and cells like you are pushed inward by physics and crowding. It is cozy in an unpleasant way. You bump other red cells like commuters packed into a late train. Occasionally, you brush against a white blood cell, larger and lumpier, a patrolling security guard that never clocks out. And you start to understand why the lab felt familiar. Because this is also a containment facility. Only instead of doors and badges, you have valves and pressure gradients. Instead of fans, you have a heart, a muscular pump that never gets a weekend. Each heartbeat is not a poetic thump. It is a pressure wave, a shove that travels through fluid faster than the blood itself moves. And it is relentless, systole, the squeeze, diastole, the refill, over and over until you either die politely in old age or something ruptures. In the arteries, the pressure is higher, the walls are thicker, reinforced with elastic fibers and smooth muscle. Elastic tissue stretches with each heartbeat, then recoils, turning a pulsing pump into a steadier flow downstream. It is a trick called the Windkessel effect, German word meaning air chamber. Human translation: your arteries act like shock absorbers, smoothing out the heart's tantrums. But you do not live in the big arteries for long. You are swept into smaller and smaller branches, arterioles, then capillaries, the narrowest corridors in the building. Capillaries are so tight that you have to fold. That soft biconcave disc shape is not aesthetic. It is engineering, maximum surface area for gas exchange, and enough flexibility to squeeze through a tube barely wider than you are. You deform like a stress ball in a fist. Your membrane slides, your cytoskeleton holds, and you ooze forward one cell at a time. This is normal. This is healthy. This is also, if you think about it too long, deeply undignified. And this is where the delivery happens. Oxygen is not carried as bubbles, and it is not dissolved well in plasma, so you carry it bound to hemoglobin, an iron-containing protein packed inside you like stacked crates. Hemoglobin grabs oxygen in the lungs, where oxygen is abundant. Then it lets go in tissues, where oxygen is scarce and carbon dioxide is higher. It is not loyalty. It is chemistry. Affinity changes with local conditions. There is a concept called the Bohr effect. As carbon dioxide rises and pH drops, hemoglobin becomes less interested in holding oxygen. Human translation: working tissues get hot, acidic, and smoky. And you drop the package faster. You do not choose, you respond. And if you are waiting for the existential horror, here it is. You, the red blood cell, do not even have a nucleus, no DNA, no long-term plan. You are a bag of hemoglobin with a membrane, built to work for about 4 months, then get recycled. Congratulations, you are disposable by design. When you get old and stiff, you cannot squeeze through capillaries as well. The spleen notices. The spleen is a soft organ that acts like a filter and a quality control desk. It forces you through narrow passages. If you cannot flex, you get trapped, eaten by macrophages, and dismantled. The iron is saved, the protein is broken down, the leftovers become bilirubin, carried to the liver, dumped into bile. Sometimes it colors bruises yellow. Sometimes it forms gallstones. Sometimes it just quietly exits your life. And the whole time, you never knew you were on probation. But the bloodstream is not only about oxygen deliveries. It is also about leak prevention, the body's own spill response. Because vessels rupture, tissues tear, cuts happen, and when they do, you need a protocol as boring and reliable as the one you followed in the lab. The moment a vessel wall is damaged, the endothelium stops acting like a non-stick surface. Collagen is exposed. It is like seeing the building's internal wiring, a sign something has gone wrong. Platelets rush in, small cell fragments that behave like paranoid contractors. They stick to the exposed collagen using a helper protein called von Willebrand factor. Say that slowly if you ever have to. Von Willebrand. Human translation, a molecular hook that helps platelets cling under flow. Platelets activate. They change shape, sprouting little arms. They release chemicals that recruit more platelets. They form a plug, a quick, messy patch. Then the coagulation cascade starts. A chain reaction of proteins, many with names that sound like bureaucratic file numbers. Factor 12, factor 11, factor 10, down to thrombin, which converts fibrinogen into fibrin. Fibrin is the net. It weaves through the platelet plugged like rebar in wet concrete. The clot stabilizes. Bleeding slows, then stops. It is beautiful in the way an emergency bulkhead is beautiful. Not elegant, necessary. And it is dangerous when it happens in the wrong place. Because the same system that saves you from bleeding out can kill you by blocking flow. A clot in the wrong artery becomes a heart attack or a stroke. A clot in the wrong vein becomes a pulmonary embolism, a sudden traffic jam in the lungs. You like to believe your body is wise. It is not wise. It is reactive. It is a set of systems that evolved because they worked often enough. Risk management, not perfection. And speaking of risk management, your immune system is the other containment crew. And it is not gentle. It is not philosophical. It is a brutal, sleep-deprived army that cannot afford to be wrong too often. You are going to drift now, still as a red cell, past a scene that looks like nothing, a slightly inflamed patch of tissue, a small breach in the border. Somewhere nearby, a cell has noticed something off. Maybe a virus, maybe a bacterium, maybe damage from heat, toxins, or your own immune system being dramatic. The first responders are not antibodies. Not yet. The first responders are the innate immune cells, macrophages and neutrophils. Macrophage means big eater. That is not a metaphor. It literally engulfs things. It wraps its membrane around an intruder and swallows it into a compartment full of enzymes and reactive chemicals. Neutrophils are even less sentimental. They arrive fast, in huge numbers, and they die fast. They are disposable grenades. When tissue is inflamed, blood vessels become more permeable. They loosen their tight junctions. Fluid leaks out, bringing proteins and immune factors with it. That leak is swelling. That leak is heat. That leak is redness. It is the body deliberately making a controlled spill. Congratulations, you are watching a containment breach that is part of the plan. Neutrophils roll along the vessel wall, sticking and unsticking like they are testing Velcro. They respond to signals called chemokines, chemical scents that lead them to trouble. They squeeze between endothelial cells, in a process called diapetesis. Human translation: they crawl out of the bloodstream through the wall without asking permission. Once in tissue, they follow gradients like sharks following blood. They phagocytose invaders, spray reactive oxygen species, release enzymes. Sometimes they release nets made of DNA and proteins called neutrophil extracellular traps, nets for short. Though we are not doing abbreviations out loud, human translation: they throw sticky webs to trap microbes. This is not clean work. It damages tissue. It creates pus, which is mostly dead neutrophils and debris. Your body wins by being willing to ruin the neighborhood. And that brings you back to smallpox in a strange way. Because a virus like variola is not trying to be evil. It is trying to replicate. The damage comes from the infection and the immune response together, a chaotic negotiation that ends with scars. Orthopox viruses are good at fighting back. They have proteins that interfere with immune signaling. They can hide from certain detection pathways. They can delay the alarm system just long enough to spread. That is why smallpox was so brutal. It was not only the virus, it was the immune system fighting something stubborn across the landscape of skin and mucosa. And in the lab, you respected containment because you respected how these microscopic arguments end. On the body, the argument is personal. Now let yourself drift again, deeper into the theme that keeps repeating tonight: boundaries and what happens when they fail quietly. Think about a single capillary in your brain. The blood-brain barrier is one of your most serious locked doors. Endothelial cells there are tightly joined. They regulate what gets in, what gets out, who is allowed to speak to neurons. It is like a high-security facility designed to protect tissue that cannot easily regenerate. Your brain is expensive to build, fragile to maintain, and very bad at repairs. Most bacteria cannot cross that barrier easily. Many toxins cannot pass. Immune cells are limited in their access. But some pathogens have learned tricks. Some ride inside immune cells like stowaways. Some exploit inflammation when the barrier becomes leaky. Some, like certain amoebas, do not ask politely at all. And you do not need to panic about that in bed. The point is the pattern. Every system is built to be good enough most of the time, and it depends on boring maintenance. When maintenance fails, the consequences look dramatic, but the causes are often dull. A clot, a plaque, a minor infection, a slow leak. And now, speaking of slow leaks, you should meet the real villain of modern human biology. Not a virus, not a bacterium, just time, calories, and chemistry. Atherosclerosis. It begins quietly in the artery wall. Low-density lipoprotein particles slip into the endothelium, especially where flow is turbulent. Branch points, curves, places where blood does not glide smoothly. Those particles get oxidized. The immune system notices. Macrophages arrive and start eating the lipid mess. They become foam cells, bloated with fat. They pile up, creating fatty streaks. Over years, the wall thickens. A plaque forms, capped by fibrous tissue. The vessel becomes narrower. The flow becomes more turbulent. The risk of rupture rises. And the catastrophe is not always the narrowing itself. It is the sudden rupture of the plaque cap. When that cap ruptures, the blood sees exposed tissue and panics. Platelets activate. Clotting cascades begin. A thrombus forms. In a coronary artery, that clot can starve heart muscle. That is a myocardial infarction, heart attack. Human translation, a section of your pump suffocates. In the brain, it is a stroke. Human translation, neurons die in minutes, and they do not come back politely. This is not meant to scare you. It is meant to underline a theme you already lived in the lab. Big disasters often come from tiny, repeated, boring processes. And the way we fight them is also boring. Lifestyle changes, medications, checkups, not cinematic, just consistent. Now, let the story pivot back to containment in a more literal way. Because you left the lab, you took off the layers, you walked into ordinary air. But the work you did does not end when you stop thinking about it. Biosafety is a culture, and cultures are maintained like immune systems. Training, repetition, correction, documentation. No hero moments, just fewer mistakes. So imagine you are back in the facility, not inside the hot zone, but in the quiet administrative spaces. Because there is always more than the bench work. There is always the aftertaste of responsibility. You are going to sit under fluorescent light that makes everyone look slightly tired and morally ambiguous. You are going to open a log, and you are going to find the most soothing sentence in biosafety. No deviations noted. That sentence is not pride, it is relief. But the days when you do find deviations, those are the days that reveal what the system is really made of. Not in crisis, in paperwork. A refrigerator temperature drifted overnight. A freezer alarm was acknowledged late. A training certification expired last month, and nobody noticed. None of these are movie scenes. They are the weak signals. Weak signals are what high reliability organizations obsess over. Facilities like nuclear plants, air traffic control, and high containment labs learn to treat small anomalies as information, not as annoyance. Because in complex systems, disasters begin as whispers. Then someone ignores the whisper because they are busy. Then the whisper becomes a habit. Then the habit becomes normal. Then normal becomes fatal. This is called normalization of deviance. It is a long phrase for a simple human behavior. You do the wrong thing once, nothing bad happens, so it feels less wrong. You do it again, still nothing. Soon, it is just how you do things. You invented a future incident. So biosafety culture fights that with boredom and social friction. The checklist that makes you pause. The coworker who corrects you gently. The supervisor who asks for documentation. Not because they enjoy controlling you, because they have read the incident reports from the past. If you want a historical example, without turning this into a thriller, think of laboratory-acquired infections. People have, over decades, been infected by pathogens they worked with. Not because they were foolish caricatures, often because of small failures, an unnoticed cut, an aerosol generating procedure, a lapse in protective equipment, an animal bite, and sometimes because the organism itself is sneaky. Brucella, for example, is notorious for infecting lab workers through aerosols. Coxiella burnetii, the cause of Q fever, is incredibly infectious. Tularemia can be acquired with tiny exposures. These are not smallpox, not famous monsters, but they are exactly the kind of quiet hazard that punishes casualness. That is why biosafety levels exist, a rough framework for containment practices. Biosafety Level 1 is basic, for agents not known to cause disease in healthy adults. Biosafety Level 2 is for moderate hazards, with lab coats, gloves, biosafety cabinets for aerosol work. Biosafety Level 3 is for serious or potentially lethal agents transmitted by inhalation, with controlled access, negative pressure, specialized ventilation. Biosafety Level 4 is the highest for dangerous and exotic agents with no widely available treatments requiring full-body suits or specialized containment. These levels are not trophies. They are a way of matching controls to risk. And risk is not only the pathogen, it is also the procedure. Centrifugation, sonication, vortexing, anything that makes aerosols increases risk. Animal work increases risk. Sharps increase risk. So, a biosafety technician does not only ask, "What is this organism?" You ask, "What are we doing with it? How could it escape? How could it reach a person? How would we know?" You are not only handling samples, you are handling pathways. And now, because your mind likes patterns, you can see that your body does the same. The immune system does risk assessment. It detects, responds, remembers. The clotting system patches leaks. The blood-brain barrier restricts access. The lungs filter. The skin blocks. Even sleep is a kind of containment, a temporary reduction in movement and behavior, lowering your exposure to the world, a nightly retreat into a controlled environment. But your body does not stop working while you sleep. It runs maintenance. Your brain cycles through stages, clearing metabolites, consolidating memories. The glymphatic system, a waste clearance pathway in the brain, becomes more active during sleep. Cerebrospinal fluid pulses through spaces around vessels, helping wash out proteins and debris. Human translation: while you lie still, your brain takes out the trash. That trash includes things like beta amyloid, one of the proteins associated with Alzheimer's disease. Sleep does not magically prevent disease, but chronic poor sleep is associated with worse outcomes in many areas. Because maintenance matters. In biosafety, you learn to respect maintenance schedules, filter changes, autoclave validation, alarm checks. In your body, maintenance is quieter, but the principle is the same. And speaking of validation, you should know that even autoclaves, those loud steel lectures, have to prove they worked. An autoclave cycle is not trusted just because the machine beeped. Temperature, pressure, and time are monitored. Chemical indicators change color when conditions are met. And biological indicators, the most convincing, use resistant bacterial spores sealed in a test vial. If the spores are killed, the cycle was effective. If they survive, the cycle failed. There is something almost comforting about that. Even in high containment, nobody just believes. They test, they verify, they document, because the microbes, again, do not care about your confidence. Now imagine the waste leaving the lab, not as bags of horror, but as carefully packaged material that has been treated, cooled, labeled, and signed off. Biohazard waste is segregated. Sharps go into puncture-resistant containers. Solid waste is autoclaved or incinerated, depending on regulations and facility design. Liquid waste may be chemically disinfected, then disposed according to strict protocols. In some high-containment labs, effluent decontamination systems treat wastewater before it leaves. Heat treatment Chemical treatment, filtration, because sinks and drains are also pathways. A building like this does not only contain what you can see, it contains what you flush. Even the air exhaust is treated like a suspect. High-efficiency particulate air filtration, sometimes in multiple stages. Filter housings designed for safe replacement. Maintenance done with procedures as careful as bench work. Because eventually, someone has to change the filter. And that someone is also you, or someone like you, wearing layers and following steps. There is a particular kind of humility in that. You can do beautiful molecular work, sequence genomes, develop diagnostics, and then you spend an hour verifying a pressure gauge. It is not glamorous. It is reality, and reality is the tone of this entire job. Sardonic, steady, allergic to drama. Now let your attention slide to another quiet hazard that biosafety people think about, not because it is exciting, but because it is common. Human behavior. People get tired. People get sick and try to power through. People hide mistakes because they fear punishment. People rush because they want to go home. So a good safety culture tries to make honesty easier than concealment. It treats incident reporting as learning, not as shame. It encourages speaking up when something feels off. This is not just kindness. It is engineering. Complex systems require feedback. If people hide small failures, the system cannot adapt. Then the failures pile up until they become visible in the worst way. So you log the near misses, the tube that almost slipped, the glove tear noticed early, the label that was hard to read, because near misses are rare. Now, let us bring smallpox back briefly, not to sensationalize it, but to anchor the concept of why we still guard certain samples. Smallpox is eradicated in nature, but the virus exists in secure repositories, and there are concerns about synthetic reconstruction in a world where biotechnology is spreading. That is a complicated topic, and it is not a bedtime argument you need to resolve. But it is part of why biosafety and biosecurity overlap. Biosafety is about preventing accidental exposure and release. Biosecurity is about preventing theft, misuse, and intentional release. In a high containment facility, you see both. Access control, background checks, inventory management, two-person rules for certain actions, cameras in sensitive areas, audits. Again, not because everyone is a villain, because consequences are heavy and prevention is cheaper than regret. Your work, even as a technician, is part of that web. You verify who enters. You confirm documentation. You notice when something is out of place. And when you leave, you carry none of it with you, but you carry the habits. You wash your hands longer than most people. You notice when a restaurant kitchen looks careless. You cringe when someone says, "It is probably fine." Probably is not a control measure. Now, speaking of control measures, there is a fascinating, oddly soothing concept in biosafety called the hierarchy of controls. It is a way of ranking safety strategies from most effective to least. At the top is elimination. Remove the hazard entirely. Next is substitution. Replace it with something less dangerous. Then engineering controls, like biosafety cabinets, ventilation, sealed systems. Then administrative controls, training, procedures, scheduling, signage, and finally, personal protective equipment, gloves, gowns, respirators. People love personal protective equipment because it feels like armor, but it is the last line. It depends on humans wearing it correctly every time. While tired, engineering controls do not get tired. Administrative controls try to shape tired behavior, and elimination is the dream. Do not have the hazard at all. Smallpox eradication was elimination in nature, but in the lab, you cannot eliminate the hazard if the goal is research and preparedness. So you lean on engineering, administration, and protective equipment. Layers again, always layers. And now, because your mind has been drifting between lab and body, between microbes and blood, we can connect the two in a way that feels strangely practical. Many of the rules you followed in the lab are reflections of how infection actually happens in humans. Respiratory protection matters because many pathogens enter through mucous membranes. Eye protection matters because eyes are wet, exposed tissue. Hand hygiene matters because hands touch faces constantly. Humans are not just vulnerable because pathogens are powerful. Humans are vulnerable because we are constantly touching ourselves. Your fingers go to your mouth, to your nose, to your eyes, to your phone, then back to your face. It is a cycle as reliable as your heartbeat. So when you were trained to keep hands away from your face, you were being trained to interrupt a very old habit loop. And that brings us back to the most boring, most important part of leaving any controlled environment, the final check. In some facilities, you may have a health monitoring program, baseline serum samples stored. So if an exposure occurs, your immune response can be compared. Vaccinations required for certain work, regular fit testing for respirators, medical evaluations. Again, not drama, just preparation. If you worked with orthopox viruses historically, vaccination might be considered, depending on the work and policies. The smallpox vaccine has risks, especially for immunocompromised people. So, it is weighed carefully. That is another uncomfortable truth. Safety measures are not free. They have trade-offs. Even the protection can hurt you in certain contexts. That is why biosafety is a discipline, not a vibe. Now let the narrative drift one more time to the idea of what happens when an invisible system fails in a way you cannot feel. In the lab, you worried about aerosols. In your body, aerosols have an equivalent, emboli. An embolus is something traveling in the bloodstream that should not be traveling. A clot fragment, an air bubble, a fat droplet, even amniotic fluid in rare obstetric emergencies. Most of the time, tiny bubbles are filtered by the lungs. But if enough air enters, or if it enters the arterial side, it can block flow. An air embolism is not common in everyday life, but it is a known hazard in medicine and certain injuries. Air in blood is not just a bubble. It is an obstruction, a surface that triggers clotting, a disruption in a system built for liquid continuity. Your body hates discontinuities. It hates leaks. It hates foreign surfaces. It hates surprises, which is why, again, boredom is protective. And now, because you are listening to a story about biosafety, you might wonder something quietly. If we are so careful, if we have all these layers, why do lab accidents still happen sometimes? The answer is not satisfying. Because humans are not machines. Because systems age. Because training varies. Because complacency grows when nothing happens for a long time. And because nature does not need you to make a huge mistake. It only needs a small one in the right place at the wrong time. So the best labs are not the ones that claim perfection. They are the ones that practice recovery. Recovery is a concept from safety science. It means you assume errors will occur and you design the system to catch them early, limit harm, and return to safe operation. In your body, recovery is wound healing. In your lab, recovery is spill response. In aviation, it is redundancy and checklists. In life, it is noticing you are tired and stopping before you do something irreversible. Recovery is not glamorous. It is mature. Now, let us zoom back in one more time to the bench level because there are still quiet details worth tasting. Consider how samples are transported even within a building. You never carry an open tube. You use sealed primary containers, then a sealed secondary container, leak-proof. Sometimes a rigid tertiary container for moving between areas. Surfaces are wiped before leaving. Labels are verified. Routes are planned to avoid busy corridors when possible. Elevators may have rules, depending on the facility. This sounds excessive until you imagine dropping a tube in a public hallway. Not because it would instantly infect everyone like a movie, but because it would create uncertainty, and uncertainty is expensive. You would have to assume contamination. You would have to isolate the area. You would have to decontaminate. You would have to monitor exposures. You would have to report. Most safety is about avoiding expensive uncertainty. Even the way you open a package matters. Outer packaging is considered potentially contaminated. Inner packaging is the true barrier. You open from the outside in, keeping clean hands clean. Just like you removed your protective layers in a specific order. Dirty to clean, outside to inside. Always folding contamination inward. That folding inward is a motif. In clotting, fibrin traps the mess. In immune response, abscesses wall off infection. In lab practices, waste is sealed and autoclaved. Life contains problems by surrounding them. And when containment fails, the next strategy is often sacrifice. Kill tissue to save the body. Destroy samples to protect the lab. Shut down a room to protect the building. It is cold, but it works. Now, there is another layer of the biosafety world that most people never consider. The concept of validation and certification of spaces. Biosafety cabinets are not trusted because they look clean. They are certified regularly. Airflow is measured. Filter integrity is tested, often with aerosolized test particles and photometers that detect leaks. If a high-efficiency particulate air filter has a breach, even a tiny one, the cabinet is taken out of service because a tiny breach is enough to ruin the whole premise. Rooms themselves may be tested, pressure differentials verified, smoke tests used to visualize airflow direction. Smoke tests are oddly beautiful. A thin fog drifting in a controlled stream, showing you invisible borders. It is one of the few times airflow becomes visible. And it is satisfying in the way a map is satisfying. But it is also a reminder. All of this safety depends on fans, seals, and power, which is why backup power exists. Generators, battery systems, alarms that call people at home. because the building cannot be allowed to simply stop breathing. In the body, you have the same dependence. Your cells need oxygen continuously. Your brain is especially demanding. You can survive weeks without food, days without water in many cases, but only minutes without oxygen before damage begins. The lab's ventilation is like your respiration. The cabinet's airflow is like your mucociliary clearance, those tiny hairs in your airways moving mucus upward to be swallowed or coughed out. You are always clearing particles, dust, pollen, microbes. Most of the time, you never notice until you get sick, and suddenly, mucus becomes your entire personality. And yes, mucus is part of containment too. It traps particles, it holds them, it keeps them from reaching deeper tissues. It is not glamorous. It is sticky, salty, full of proteins and immune molecules, and it works. Congratulations, you are protected by slime. Now, if you want one more practical connection between lab and body, consider the concept of dose. In toxicology and infectious disease, dose matters. How much of an agent you are exposed to influences whether you get sick and how sick you get. Some organisms have a very low infectious dose, meaning it takes only a few particles to cause infection. Others require a larger exposure. That is part of why aerosols are such a concern. They can deliver particles deep into the lungs efficiently. In the lab, you control dose by preventing exposures, using containment, and cleaning. In the body, you control dose through barriers, immune responses, and behaviors. And this is also why, historically, smallpox was so effective at spreading. It transmitted through close contact, respiratory droplets, and contaminated materials. It had a population with no immunity for long stretches of history. It had time. Time is always a cofactor. Now, let us turn to another quiet part of biosafety work that deserves respect: the psychology of checklists. Checklists are not insults. They are external brains. In high-stakes environments, checklists reduce cognitive load. They catch slips not because you are stupid, but because you are human and distracted. A slip is when you know what to do, but you do something else by accident. A mistake is when you do not know what to do, or you choose the wrong plan. Checklists are best at catching slips. Things like, did you seal the container? Did you label it? Did you disinfect the outer surface? Did you log the movement? When you are tired, your working memory shrinks. You drop steps. You assume you did something because you usually do. The checklist forces you to confront reality. And yes, it is annoying. That annoyance is part of the design. It slows you down. Speed is seductive. Speed makes you feel skilled. But in biosafety, speed is a trap. Now, shift your perspective once more, not to the lab bench, not to the bloodstream, but to the quiet space where these worlds meet, your home. Because leaving the lab does not mean you stop caring about contamination. It means you stop needing to. At home, most people have no idea how many invisible risks they manage without structure. Food safety, for example, is biosafety at a domestic scale. Raw chicken is a biohazard. So is a cutting board soaked in meat juice. So is a sponge that never dries, breeding bacteria like a damp apartment. You separate clean and dirty surfaces without calling it that. You wash hands after touching raw meat. You heat food to kill pathogens. You refrigerate to slow growth. It is the same logic with fewer badges. And when people ignore those rules, the consequences are usually less dramatic than in movies, but still unpleasant. Foodborne illness, Salmonella, Campylobacter, E. coli, vomiting and diarrhea, your body flushing a mistake. Your gut is another containment system. Acid in the stomach kills many microbes. Bile disrupts membranes. The intestinal lining acts as a barrier. Your microbiome competes with invaders, a crowded ecosystem that does not welcome new tenants. And when that system is disrupted, you notice. Antibiotics can wipe out protective bacteria. Then opportunists, like Clostridioides difficile, can bloom, causing severe diarrhea. That is a hospital-associated hazard and a reminder that even medicine has side effects. Killing microbes can open space for worse ones. The theme, again, is boundaries and unintended consequences. Now, you are still not done with your shift in the larger sense, because the world of biosafety does not stop at microbes and tissues. It extends to policy, to ethics, to logistics, to the human desire to understand what can kill us. And one of the most uncomfortable facts is that the safer we get, the less practice we have at responding. When smallpox was common, doctors knew what it looked like. They had seen it, they feared it, but they recognized it. Now, most clinicians will never see a case. That is good. It is also a vulnerability, so preparedness becomes a kind of simulation. Training exercises, stockpiled vaccines, plans for contact tracing and isolation. Coordination between labs and public health agencies. Public health is another boring hero. It runs on phone calls, forms, databases, and people who can tolerate repetition. If you ever wonder why outbreaks can spiral, it is often because logistics fails. Not because science is missing, the science can be clear, and the response can still be chaotic, because humans are not built for sustained, boring discipline. Some are. Most are not. That is why biosafety technicians exist. They are professionals at sustained discipline. And you, listening, are now a little more aware of the kind of work that keeps disasters from happening loudly. Now, let us drift back into the body one more time, because there is one more system that mirrors the lab's obsession with flow, and it is running right now, even if you are asleep. Your lungs. You breathe air that is full of particles, not visible clouds, just constant dust, pollen, fibers, and the occasional microbe. Your upper airways act like a filter. Nasal hairs catch larger particles. Mucus traps smaller ones. Cilia move mucus upward, a slow escalator toward the throat. If particles reach the alveoli, those tiny air sacs where gas exchange happens, you have macrophages waiting. Alveolar macrophages crawl along surfaces, eating debris. This is why lungs can handle a lot until they cannot. Fine particles, smoke, chronic pollution can overwhelm clearance. Some particles are toxic. Some trigger inflammation. Some carry chemicals that damage tissue. And infections exploit this interface. Respiratory viruses bind to receptors on airway cells. Influenza uses sialic acid receptors. Severe acute respiratory syndrome, coronavirus 2, uses angiotensin-converting enzyme. 2 receptors, names aside. The idea is simple. Viruses are keys. Cells have locks. If the key fits, the virus enters and hijacks the machinery. The immune system responds. Inflammation increases. Mucus production rises. Coughing begins. A violent airflow event designed to expel particles. Coughing is your body's alarm, loud, annoying, and purposeful. Just like the lab alarms, and sometimes the response harms you. Too much inflammation in the lungs can fill alveoli with fluid and immune debris. Gas exchange fails. You suffocate while surrounded by air. That is one of the cruelest mechanics of severe pneumonia. The border becomes clogged with the body's own defenses. You see the pattern now. Containment is not free. It has costs. Now, allow the narrative to settle into a quieter, administrative corner again. Because after a shift, after decontamination, after logs, there is still review. In good labs, there are routine safety meetings, not dramatic tribunals, just regular conversations about what worked and what did not. People discuss near misses. They review procedure updates. They talk about supply issues. Because yes, supply issues can become safety issues. If you run out of the right disinfectant, people improvise. If you run out of the right gloves, people double up the wrong ones. If equipment is delayed for repair, people work around it. Workarounds are where accidents breed. So part of biosafety is boring procurement, ensuring the right supplies are available, ensuring maintenance is scheduled, ensuring training is current. This is why the job is not just science. It is operations. And operations is where most people lose interest, which is exactly why it matters. The world is held together by people doing operations correctly, while nobody applauds. Now, you might be wondering, very gently, about the title again. Why you would not last a day? And the answer keeps returning to one thing. It is not fear. It is not weakness. It is temperament. Can you do the same careful motion 100 times without getting bored and speeding up? Can you tolerate checklists without feeling insulted? Can you accept correction without taking it personally? Can you document your work even when you want to go home? Most people cannot. Or they can for a while, then they drift. And drifting is the enemy. Now, let us pause the drift with one more grounded detail. The concept of exposure response. When the worst case happens, if a lab worker has a potential exposure, the response is structured. Immediate first aid, like washing a wound, flushing eyes, removing contaminated clothing, reporting to supervision and occupational health, risk assessment based on agent, route, dose, and circumstances. Sometimes there is post-exposure prophylaxis, medication or vaccination given after exposure to reduce disease risk. For some agents, antivirals exist. For others, supportive care is all that can be offered. Monitoring may follow, with temperature checks, symptom logs, sometimes quarantine, depending on risk. Blood samples might be collected for baseline and follow-up. This is not because the lab expects failure. It is because it respects reality. Even the best systems have breaches sometimes. So you plan for recovery. And now, with all these systems in mind, your mind can keep wandering. Not to an ending, not to a conclusion, but to the next quiet mechanism that keeps you alive. Because blood and air and immune cells are only part of it. There is another invisible network, slower, quieter, and strangely similar to the way contamination spreads when you are not watching. A fluid system that drains, filters, and returns. A body-wide house